parameter passing via table. So, this is the strategy that we said is very important, or very one of the simplest way, or simplest at the same time it has got flexibility. So, we have got this for this procedure call. So, we have for this system call. So, we have got a number of parameters to pass, and those parameters that we want to pass. So, they are loaded into some memory locations, and then this parameter the parameters for the call. So, we load the address x for the system call. So, this is the system call 13 that is that the program is going to make. So, x is the parameter x is loaded onto a register, and then that is passed on to this thing. So, this x is actually an address register, and that holds the block of parameters, the address of the block of parameters that we have in the system for this particular call. So, it is like this, that if this is the memory. So, maybe in this portion of the memory the parameters are all copied, and in the x register. So, we have the address of this. So, when this x is properly loaded with this particular address, then at the operating system implementation level of the system call. So, it can use that x register to locate the parameters that have been passed in the block. So, this way, by using this table type of structure, so we can pass the parameter for this system call. There are different types of system call. As I was discussing, there are different types of services. So, each of these services that the operating system provides. So, there is a set of system calls that are possible. So, they can be grouped roughly into 6 major categories. Some of the system calls are process control related, some of them are file related, file manipulation, some of them are for device manipulation, some of them are for information maintenance, some are for communication, some are for protection. Okay. So, this will see sometime later, like how these system calls are there. So, to start with, the system calls for process control, they will create process and terminate process. So, these are some of the related system calls, like create process or terminate process. So, we may want to end a process or abort a process. So, ending is just terminating that process, or aborting is in between there is some erroneous condition that has occurred. So, that has to abort the call. Then there are load and execute. So, maybe some program has to be loaded or some process has to be loaded, or process has to be executed. So, load means it will be loaded from the content will be copied from the secondary storage or disk into the main memory. So, that the process becomes ready for execution, and later on when the process is given CPU time. So, it will be executing. So, that is the execute. So, these are two different operations. One is making the program ready, or making the process ready for execution by copying its content from the secondary storage, and the other one is to execute the process, that is giving the CPU to the process. So, get process attributes and set process attributes. So, some of the attributes of the process, like who is the owner of the process, then how much time we should give it, what is the priority of the process. So, that way we can try to get the attributes of the process, or sometimes we may want to set the process attributes. So, it may so happen that we want to reduce or increase the priority of a process. So, that can be done by the system user, the system administrator, but the operating system should provide some system call by which that can be carried out. Then some system call, some process may like to wait for some time, that between two operations it wants to introduce some delay. So, it wants to wait for some time. So, when that time is over, then the process should be informed, and the process will resume its execution from that point. Then wait for event or signal event. Sometime a process may like to wait for some event to occur, or it may want to inform some process, that some other process, that okay, the event, some particular event has occurred, so that other process can continue. So, it may so happen that I have got two processes P1 and P2. So, P1 is P2 is waiting for some event which will be triggered by P1. So, P2 for the P2, so it is waiting on some event E. Okay. So, that is the wait system call, and this process P1, so it will be doing that signal on the E. So, that way it will signal that the event has occurred. So, that is the wait event and signal event. So, they are two different events for which there must be system call available, so that they can be utilized by the processes. Then allocate and free memory. So, some process may require more storage, because as we know some while writing in some high level program. So, we want to create some dynamic storage. So, the dynamic storage creation is by means of this allocate request for some dynamic space, and when that space is no more required, we would like to free that space. So, this allocate and free. So, these are the two things. Then dump memory if error. So, if there is an error that has occurred, so we dynamically that error has occurred while the program was running, and you may be familiar with getting this type of errors. So, if you particularly if you are running program on a Unix or Linux operating system, something like this particular error message, segmentation fault core dumped. So, you might have seen this message. So, this what this message means is that, so I have a program. So, in that program I am writing say x equal to something, where this so this is for normal variable assignment. So, if I have got a pointer p and I write that star p equal to something, and until and unless this p is properly initialized. So, when this operation is going to be executed, so it may there is a very high chance that this address, the current value of p, that is the address of the location that should be modified, is not within the valid address range for this particular process. So, as a result, so this is a segmentation fault. It is trying to access some location which is beyond the segment that is available for this program. So, that is a segmentation fault, and when this segmentation fault occurs, the user needs to check whether the fault has really occurred or not. Okay. So, what was the situation that led to p having some other value, some undesirable value. So, for getting that trace, so we need to know like how this point was reached in program execution, and that is the total runtime image of the process that is executing. So, that is called the core of the program. Now, so when this segmentation fault occurs, so if this code is dumped, then later on some debugger can be used to trace why exactly this particular fault occurred. So, that is the segmentation fault code dumped, and it is normally it is a huge file compared to a normal small the actual program code, because program code is small, but the program code maybe it is making some recursive calls and all. So, this core becomes very large. So, that way this is also very important, like operating system, it should be able to dump the memory content if there is an error, so that we can figure out what went wrong with the program. Then debugger is required for determining bugs. So, we should be able to single step execution. So, debugger is for checking whether there was why this particular situation has occurred, when the program is not running properly, what is the problem, why is it not running properly. So, you may like to have this thing, like for example, I might have written a program that does all this computation x equal to y plus z, etc., etc. Now, after executing this line, whether this line was properly executed or not, so how do I check it? So, I should be able to see what is the value of y, what is the value of z, and what is the value of x. So, after this line has executed, so if I find these values and see that x is really having the value y plus z, then I know that up to this much the program has executed correctly. But if I get something else, that means there is a problem somewhere, maybe this particular statement or some program or some statement in the other part, in the earlier part of the program. So, how to do this thing? So, for this we must have some debugging facility. So, the system must have a debugger, so that I can do this check. So, it will allow me to check the content of some of the memory locations and the CPU registers. And also I should be able to run a program line by line. So, if these are the different lines of the program in the particularly in the source level, like this line may be x equal to y plus z, this line may be p equal to x into m. So, like that. So, I should be able to stop. So, normally if you start executing a program here, So, it executes all these lines and then comes out, it terminates, but I do not want it. I want that the after I have initiated the operation. So, the program should get suspended here, and then I will be able to check the values of x, y and z. Then if I say go, then it will execute the next line and again stop here, again I will be able to check the values of these variables, then it should go like this. So, in line by line it should proceed, not the whole thing in a single go. So, that is the single step execution that is there. So, single step execution is helpful in the program debugging phase. So, normally when the program is being developed initially, so there are lots of logical bugs in the program, then this debugger and this single stepping facility. So, these are really required, particularly if the logic of the program is complex. So, this way this debugger facility they are provided by means of system call services. Then there are locks for managing access to shared data between processes. So, as I said that if there is a variable shared variable x. Now, if process 1 is trying to write onto this and process 2 is trying to read this, then when process 1 is modifying this value of x, then this content of x is not final. So, it is in some the value that is read by P2 may not be a correct one, as the value x was undergoing some changes. So, what I can say, when this P1 is accessing x, P2 should not be allowed. Similarly, when P2 is reading x, P1 should not be allowed to modify. So, for that I can have some sort of lock around this, and to access this x I should get a hold of the lock. So, if I get the lock permission, then only I should be able to proceed. So, this type of locking mechanism must be provided by the operating system calls, so that this sharing becomes consistent. So, we will look into this in process synchronization chapter, as we will see later. Then for file management, we have got a number of system calls like the creating a file, then deleting a file, open and close files, then read, write or reposition. So, these read, write we understand. So, reposition actually means that if this is a file, now when you open the file pointer is set at the beginning of the file. So, if you read from here, then you will be getting the lines one after the other, or actually you will be getting word the character by character, or this depending on the size of that read. In the read system call, we have to tell like how many bytes we want to read. So, here I have to tell that FP, and the other parameter that I want need to give is the number of bytes that I want to read. There is of course another pointer, the buffer pointer is there. So, if this read is successful, it will read from the current position of this file pointer number of bytes and put it into the buffer. Now, after that the file pointer will advance to the next, suppose this much was the number of bytes read. So, file pointer will come here. So, if you issue another read here, so it will start from this read from this point and continue. Sometimes we may want to skip some part of the file for reading, and that is done by this reposition type of system calls. So, normally in C programs, so you will find there is a call lseek. Okay, so that will place that file pointer somewhere later in the file. So, this reposition system call is there. Then we have got system calls for get and set file attributes. So, that will be allowing us to get who is the owner of the file, what is the size of the file, when was it created, when was it last modified, etc. So, this file management related calls, so they should be there in any operating system. Next, we will see the device management related call. So, there may be request for device, then release a device, then read, write, reposition. So, this is the same thing. So, you want to read the content from the device or write or something onto the output device, or we want to advance that the read write head, okay, that repositioning the head. Then get device attributes, set device attributes, logically attach or detach devices. So, the device is there, but we want to get it attached to the system or attached to the program. So, that is the attachment, or we do not want that device anymore in my program. So, we want to detach the device. So, these are the services provided by the under the device management category. Then maintenance related calls like get, time or date. So, we may for example, if you are trying to keep the information about which user is using how much time, using the system for how much time, then these are important, like get time or date, set time or date, get system data, set system data, then get and set process file or device attributes. So, these are some of the in maintenance related calls or maintenance related system calls that are available in operating systems. Okay. So, all operating systems will have some variant or the other of these calls. Then for communication between the processes, so we have to have create, delete this type of communication connection. So, this is one type of calls. So, if the message passing model, we have got send, receive messages. If we have got shared memory model, then we want to create or gain access to shared memory regions. So, it is like this, like whenever you have got this multi-processing system, then one particular model that we have is the message passing model. So, in the message passing model, what is done between the processes that wants to communicate between themselves. So, there will be a message queue. So, this process will send a message to this one. So, every process, so you can think that this process has got a queue associated with it, which we call the message queue, and similarly this process also has got a message queue associated with it. So, when P1 wants to tell something to P2, so what it will do, it will send the message to this message queue. Then accordingly this message queue content, so as soon as some message has arrived in message queue, so when P2 wants to read from the message queue, it will get that message into it. Similarly, P2 if it wants to send some message to P1, so it will actually be written onto the message queue of P1, and later on when P1 reads from the message queue, will get the message. So, this is one type of communication mechanism that many operating systems do support, and naturally you need to have this type of messages. You should have the system call for the send, receive message. To it may be sending to a host name or to a process name. So, this is just shown in terms of two processes, but it may so happen that physically this M1 this P1 is in system M1 and this P2 is in system M2, two different computers. So, then also we would like to have this communication mechanism. So, we should be able to send, receive messages across hosts or across processes, or it may be from client to server. The client wants to send some message to the server. So, that way from client to server some message may go, and from server to client also some message may go. So, that we must support this type of system calls in the operating system. Then the shared memory model is used. So, in shared memory model is a more tightly coupled system. So, in shared memory model what happens is that, so I have got say these are the two processes, say P1 and P2, and both of them are using the memory for accessing and getting the so this P1's this may be the portion of the memory which is dedicated for P1. So, this may be the portion of the memory dedicated for P2. So, normally when P1 is running, so it will be executing this piece of code and P2 will be executing this piece of code. Now, if there is a variable x, okay, which this P1 and P2 wants to share between them, then you see there is no way, because the copy of x that I have in P1, so this is memory location here, and copy of x that I have in P2, so that is there. So, they are not the same x. Okay. So, what we need to do is that we should have some portion of memory which we call shared memory. Okay. So, this is called shared memory, and then somehow P1 should have a pointer to a location in the shared memory. So, it has a pointer to this location in the shared memory. P2 also has got a pointer to this location in the shared memory. Now, if that can be established and with a proper permission setting that this particular location is accessible by P1 and P2 only. So, then if P1 wants to write something, so it can go by this pointer. So, suppose name of this pointer is say P and this pointer is say Q. So, if P1 writes like star P equal to some 5, then what will happen? So, this particular location will get modified to 5. So, and then if P2 it looks for the value of star Q, then it will find that the value is equal to 5. So, it will get this value 5 there, so value of x there. So, this way we can have the sharing. So, this for the shared memory realization we should there should be system calls by which we can create these memory regions to be shared, and we should gain access to those regions. So, there are system calls which are useful for this creating this shared memory. We should be so that is there. So, we will come to those calls later. Then transfer status information. So, from one process, so we may need to tell what is the status of the process at this point of time. So, that way the status information needs to be transferred. Then attach and detach remote devices. Some device is on a remote system. So, for sometimes we want to use that system. So, you make an attach call, and sometimes after some time when the usage is over, we want to detach from that device. So, that way it is detached system call. So, those system calls are to be provided by the operating system. For protection, we should get control access to resources. So, this is important. So, we should have system calls that will control access to resources, get and set permissions, allow and deny user accesses. So, these are the protection related system calls that should be available. So, if you look into any operating system, so this the system calls they can be grouped into these categories. For example, so this is say from the process control group. So, if you look into this Windows operating system, so there are calls like create process, exit process, wait for sibling object. So, like that. Similarly, for Unix call, Unix system or Linux system, so we have got the corresponding system called like fork, exit and wait. So, this create process of Windows is similar to fork in Unix, exit process in Windows similar to exit in Unix. So, like that. Similarly, for file manipulation in Windows we have got create file, in Unix or Linux we have got open. For reading a file we have got read file here and read here, write file for writing, write for writing. So, like that we can have different types of system calls. So, we have got close handle for closing the file. So, we have got simple close to close the file. Okay. So, these are the some of the calls, like for device manipulation we have got set console mode. Similarly, we have got this IOCTL. So, that sets various parameters related to the IO operation. Then we have got read and write system calls from the device. So, here also we have got read write. So, in case of Windows, you see that device manipulation we have got read console, write console, they are different from read file and write file calls, whereas in Unix system, so they are same, the same read write system calls are used for both file and devices. So, in Unix system the files and devices they are looked in a more uniform fashion compared to say Windows OS. Then for information maintenance, so we have got get current process ID in Windows, we have got get PID in Unix. So, like that there are many such system calls for every operating system. So, you can find this list documented in the manual. So, let us see how this standard C library routine printf is executed. So, we have got a piece of program where there is a printf statement. So, this printf this will be this is a library call, library function, they are available in the to the C programmer, and when this is done, so this program was executing in user mode. So, it when this printf call is found, so it goes to the standard C library, and the standard C library it will transform this call into the write system call for the underlying operating system. So, it makes a system call write. So, here it is going into the kernel mode of execution. So, it is the code for printf. So, it will convert this into a write system call, and the write system call is coming to the write system call interface, and then it will go to the actual execution of the write system call. After the write system call is over, so it comes back to the standard C library, and from there it goes back there. So, this way this printf library routine is invoked from the user program, and that in turn invokes the write system call. So, system programs they provide a convenient environment for program development and execution. Some of them are simply user interfaces to system calls, others are considerably more complex. So, system programs, so some of them may be as simple as just making the system call, some programs may be more complex. So, we will see how are they divided into different classes. As there are different parts of the operating system, so system programs may be also of different types. There are some programs for file manipulation, some for status information, and sometimes stored in a file modification. Then programming language support, program loading and execution, communication, background device services, and application program. So, most users view of the operating system is defined by system programs, not the actual system calls, because the system calls may not be visible to the user. So, they just see the system programs that are available. So, system programs for file management like this create, delete, copy, rename, print, dump, list, and generically manipulate these files and directories. So, these are the file management related system programs. So, why do we call them as program? Because of several reasons, like if you look into for example, the Unix or Linux operating system. So, you will be finding that whenever suppose I have got a user whose name is user 1, normally the user 1 will have a directory /home/user1, and in this directory maybe the user has got a program ABC. When the user gives the program for execution, so it runs. But sometimes the user may need for running some other system program. Those system program like say to copy a file, we have got a command cp. Now, there is a specific directory in my system where the code for cp is located. So, it may be the directory /bin okay, and /cp. So, this is the file. In the /bin directory, we will find a file whose name is cp. This is an executable file. So, this is actually the program that will be executed if you give the cp command. So, the cp command will in turn use the system calls, like it has to for executing this cp command. So, it has to open the source file, it has to open the destination file, it has to do a number of read and write system calls. So, as we have seen previously, it has to do a number of read write system calls in a loop, and then finally close the files. But as a user of the system, we do not see this thing. So, this part is not visible to us. So, we just see that there is a file cp. So, that cp is a system program, and it in turn uses the system calls. So, system calls are not visible to the user. What is visible is the system program. And the reason why is it called a program? Because they are also kept in certain directories and they can be executed from there. So, this in some cases these system programs can be modified, like you can have your own version of the program cp and put it into the /bin directory. So, that it will be using your program for copying rather than using the system program cp. From some operating systems it may not be possible. So, there these system programs are not available separately. So, they come as part of the command line interface directly. So, that way it is not so they are not modifiable, but say operating systems like Unix, Linux, so they will allow you to do this thing. So, these are file management related system programs. Then for status information, so some programs ask the system for information, date, time, amount, available memory, disk space, number of users. So, there are some programs for doing that. There are some programs that provide detailed performance logging and debugging information. So, again they will be in turn using system calls, but that is not visible to the user. Typically these programs format and print the output to the terminal or other output devices. So, it is like this, as I said that particularly if you look into the Linux operating system, the command ls that lists the files that are there in the directory. Now, this ls command, it has got a number of options like ls minus l, ls minus al. There are lots of commands, so lots of arguments that you can pass to ls. Now, when this ls is implemented as a system call, so system so it gets the list of files and all, but that it gets the complete data is available to it, but that data how it will be presented to the user, so that is the concern. So, this is the whole raw data that the system call has returned, and then it is formatted in proper fashion depending upon the options that are specified by the user, so that it comes in a in the way the user was looking for. So, this cosmetic changes or this format conversions are done by the system programs, and the system calls they will return the raw data from the system, and the system programs they will format it in a in the form that the user has asked for. So, this is the thing that they typically they format and print the output to the terminal or other output devices, and some systems implement a registry. So, used to store and retrieve configuration information. So, this configuration information is stored, so that for update and all, so it becomes easy. So, we know where to look for the update and all. So, this is there. So, sometimes we have got this configuration. Then file modification. So, this now we have got these text editors that can do file modification. Then we have got programming language support. We have got program loading and for program loading and execution there are system programs. For communication also there are system programs. So, we will look into this in the next class.